All right, AGS1, we are back with mod 6.2. Is it right? Today's essential question, what do rotations have to do with perpendicular lines? So today we're talking about rotating figures and perpendicular lines. First up, the definition of perpendicular lines is two lines that intersect at 90 degrees. Now, it doesn't have to be a perfectly straight up and down and left, right. They can be kind of rotated different ways, floating in space. But if you do have a perfectly horizontal line and a perfectly vertical line, they will always meet at 90 degrees. So this means that when we're working with graphs and we have all these XY coordinates, all these lines on the graph all meet at 90 degrees because they're all perfectly horizontal and perfectly vertical. We're going to do 3 examples today that are very similar. The first step with all of them is to draw line AB. So that little symbol on top of the A and B just means connecting the 2 points with a line. So the first point is 2, 3. So if I count over 2 and up 3, then 2, 3 is right here. Then the next point is 4, 7. So I go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So this is A, and this is B. Get rid of my counting mark so we don't get confused. Okay, the next step, oh no, wait, I didn't do the first step, which is connect them with a line. The next step, find a point C that makes AB a hypotenuse. So a hypotenuse is the longest side in a right triangle. So if I kind of zoom in here, because all of these horizontal and vertical lines always meet at 90 degrees, that means I can trace down to this spot here and trace over to this spot here, and that means this will be a 90-degree angle. So this is point C. The next step says rotate ABC 90 degrees about point A, 2, 3. So if it says to rotate 90 degrees, first of all, we need to make a note that anytime you see a positive rotation, I know this is kind of counterintuitive, but this is going to be counterclockwise. So any positive rotation, 90 degrees, 180 degrees, you're always going to be turning it the opposite way that a clock goes. So, you guys, we're going to turn this 90 degrees. So you can think of this triangle as like the image, or the pre-image, excuse me, and we are going to find where all these points land if you rotate them 90 degrees. The first thing I want to focus on is this side right here, AC. Now, if AC was to get rotated 90 degrees, that means you would take that side and rotate it all the way to here. So A would stay in the same spot because we're rotating about the point 2, 3. So the whole thing, you can picture that there's like a safety pin or a push pin in the triangle right there, and we're just going to twist the triangle this direction. So the point, or the side AC, is 2 units long, and it used to be right here, but it's going to transfer to here. That means that this point down here is going to be A prime, and this point up here is going to be C prime. Remember that you use a little prime to indicate that it's an image and not a pre-image. Now, from C to B here, this is 1, 2, 3, 4 units long, but you have to picture that that got rotated 90 degrees. So this point B got rotated all the way over here. Sorry, I realize I'm using language that you can't see. I'm using my hands on the screen. But the main thing is that this is 1, 2, 3, 4 units long, which means we're going to go 1, 2, 3, 4 units this way. So this is B prime. And then from A prime to B prime, we can just connect the hypotenuse to say this is going to be the hypotenuse of the image. So that was step C. We rotated it 90 degrees about the point 2, 3. Now we need to find the slope of AB and the slope of A prime, B prime. So if I'm just counting, hold on, red. If I'm just counting blocks, remember slope is rise over run. So to get from A prime to, or sorry, from A to B, it goes up 1, 2, 3, 4, and over 2. So this is 4 over 2, which just equals 2. Now we need the slope of A prime, B prime. So we're going to do the same thing. But notice that in general, the slope of A prime, B prime is going downhill as you read it from left to right. So the slope of this guy would be down 2 and over 1, 2, 3, 4. So anytime you're going down, this is negative 2. And anytime you're going to the right, it's positive. So this is a positive 4. So the slope of A prime, B prime is negative 2 over 4, which we can reduce to negative 1/2. And that was all the steps A through D. So we drew the triangle, or we drew the points A, B, we turned it into a right triangle, we rotated it, then we found the slopes of the two hypotenusae. Let's do it all again, where A, B are different points. So first step is to plot A and B. So A is 2, 3, so I'm going to go over 2, up 3. So here's A. And then B is 5, 4, so I'm going to go over 1, 2, 3, 4, 5. 1, 2, 3, 4. So here's B. And then the next, the first step is still just to turn that into a triangle, or into a segment. Then the next step is to turn this into a right triangle. Remember that the horizontals and verticals all meet at 90 degrees. So if I go here and here, this will be my C value. Then they're going to want us to rotate this triangle about the point 2, 3. That was the directions on the first one. And we're going to rotate it 90 degrees. So we'll use a different color. Picture that this point is anchored. There's a push pin right through A. And then this side is going to get turned 90 degrees to here. So AC, or A prime C prime rather, is 3 units long and goes up to here. So this will be our new C prime. Then from C to B is 1 unit, and it's going up, but when that gets turned to the counterclockwise 90 degrees, it will just be 1 unit in this direction. So here's our B prime. And then, of course, if we connect B prime to this being A prime, it's both A and A prime, here is the image. I guess we should write that. Let's say that this is the pre-image, and this is the image. The last step was to find the slopes of A, B, and A prime, B prime. So I'll use a different color here. To get from A to B, it goes up. Should we zoom even more? Up 1. So that's up 1 and over 3. So that's rise over run. That's 1/3 is the slope of AB. So here, we'll write it here. Slope AB is equal to 1 over 3. Then A prime, B prime, if you start at B, it goes down 3 units. So this is a -3 drop, and it goes to the right 1 unit. So that's -3 over 1, which is -3. So slope A prime, B prime is equal to -3 over 1, which is just -3. Let's do it all again for this example. First step, we're going to plot 2, 3, and 7, 5. So I'm going to go over 2, up 3. They always start at 2, 3, well, in these examples. So here's A. Then 7, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So here's my B value. If I connect those with a line, the next step is to find point C, so that makes this a right triangle. Well, if I drop a line straight down and a line straight over, that means this is point C. The next step with all of these is to rotate it 90 degrees around the point A. So this becomes our new A prime. Notice that AC is 1, 2, 3, 4, 5 units long, which means that as that rotates 90 degrees this way, that it'll still be that long, but just going straight up instead of straight to the right. They'll meet at a perpendicular angle is another way to say that. So 1, 2, 3, 4, 5. Here's your C prime. Then B is 2 units up from C, which means that B prime is going to be 2 units over from C prime. So B prime is going to be right on the y-axis. And then, of course, we can connect A prime to B prime to make the hypotenuse. So notice that the triangle has rotated 90 degrees counterclockwise. The last step is to find the slope of AB and the slope of A prime, B prime. Let's go red again, keep it consist. So to get from A to B, we go up 2, over 1, 2, 3, 4, 5. So that's rise over run, a slope of 2/5. So slope AB is equal to 2/5. To get from B prime to A prime, we need to drop 5. So that's -5, and then run 2. So that's -5/2. So slope A prime, B prime is equal to -5/2. You guys, look at this interesting relationship between these two. Oh, wait, that's what we're going to talk about next. So I have a table where I'm going to fill out the slopes of all these examples. So the first example, the slope of AB and A prime, B prime, was 2 and -1/2. So this becomes 2 and -1/2. For the second example, these slopes were 1/3 and -3. And then the last example, they were 2/5 and -5/2. Now, you guys, what do you notice about, all of these were perpendicular hypotenuses, because we always were turning them 90 degrees, so they met at 90-degree angles. So all these are perpendicular slopes. If you look at 2 and -1/2, do you guys see the relationship between them? Same thing with 1/3 and -3, or 2/5 and -5/2. In general, you can say that if the first line has a slope of A over C, the perpendicular slope will be -C over A. Do you see that all of them are just upside down versions of each other, where one's positive and one's negative? So perpendicular lines in general, they have opposite signs, meaning one's positive and one's negative, and numerator and denominator flipped. The fancy way to say that is that they are reciprocals of each other. Okay, you guys, good luck with the formative today. I think if you took good notes, you should be pretty good to go.